Good morning, class. This is your instructor. I'm going to be talking about probability today. Now, probability is the possibility, the outcome, the likelihood of an occurrence. What it entails is the unsurety that is about the possibility of the outcome that you desire. So, for instance, I say, what is the chance that I could win a lottery, or I could win a lottery twice? Similarly, then there is a chance that a head out of tossing of a coin could be the outcome, or a tail could come up when a referee tosses a coin prior to a match. So it could be important for deciding matters such as who would bat first. Then it's also very important when it comes to risk management in business and hypothesis testing in psychology and in quantum physics, because you need to understand the iterations, and then there's a Markov system, and we are also going to be discussing the conditional probability, but that will be in the next lectures. In this current lecture, I'm going to be talking about the simple concepts like sample space, which is the possibility of outcomes, the total possibility, and then the experiment, which means that there's an action on my part or your part. So for instance, I say that there are a couple of people in the class and I would select two based on the highest performer and the second highest performer. So this is an experiment. Now, event would be those two people, and again that event would be culminating in my selection of those two people. So the sample set would be all students, the event would be the subset. So I say that this would be the sample, which would be all students in the class, and this could be the subset where two people are the highest performers, and this is known as the event. Okay, so this is the event, which would mean that the highest performer is the one who could be A or B, second highest. Now, again, this could mean that there's 2 out of a possibility of 48. Similarly, I could draw from a deck of cards of 52. So what is the possibility of 4 jabs or 4 A's? That could be 4 out of 52. So then, again, there's another concept associated with that, which is bringing us to the rolling of a die. Now, why this is so important is because we need to be sure, because in especially European countries, United States, not just in Muslim countries like Pakistan and Bangladesh, where there are not enough opportunities for this gambling and winning by lottery. But we do have prize bonds and random selection, and then that brings me to another concept, which is permutation. Whenever we talk about having a random selection out of a selection of people, so now this was not random, okay? So I'm going to be talking about a random outcome, which would be, I'm indifferent to any number of students. I just want to have a combination of a boy and a girl. So this could be having let's suppose if there are just 50, so there could be maybe 30, or if there are 48, maybe so there could be 32 or 35 could be boys. 32 could be boys in this case, and you could have maybe 14 or 16 girls in the class, or it could be any other combination. You could be having maybe 50-50, you could say, just having 24 boys and 24 girls. So now if I want to draw a pair of a boy and a girl, so I would be indifferent. So that would lead us to a combination, because we would be having a pair of 2 out of a total of maybe 48. So then that would be something like that. It could be something like this. But combination is going to be coming further in the lectures. However, all these concepts you have to make yourself aware with them, and also comfortable, and equate yourself to terminology such as what is a sample space, what is an experiment, what is an outcome. And this was basically part of the modern probability that was designed by Andrei Nikolaevich Kolmogorov in 1933. He wrote this book which was about foundations of modern probability, then there were other people like Blaise Pascal. In the 16th and 17th century, the concept arose because there were mathematicians who were interested in the possibility of learning about this. And then there was Christian Huygens, and then Pierre was also one of those who were influential in this. And then, okay, now we come towards the other things such as rolling of a die, like I told you. So now let's say I have these possibilities, and I'm going to be drawing the number of possibilities. Already you know that it is 6 into 6, which is equal to 36. Okay, but now when you draw the results, would be 1, 2, 3, 4, 5, and 6, and then you could have 2, 1, 2, 2, 2, 3, 2, 4, 2, 6, 3, 1. Now why I'm looking at this is because I want to probably find out what is the sum of the dice, two rolling dice, which are either distinguishable or indistinguishable based on their color. If they are the same color, they will be indistinguishable, and if they are of different colors like red, white, or white or red die, then they will be distinguishable in this case. I want to know whether the sum is less than or greater than 11. So one probability I would want to know is whether it is 11 or greater. If you can see any, you can see that this highest is culminating in 9. So I would just keep on going further. 4, 4, 4, 5, and 4, 6. Then we have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Okay. So now you know that this is 11, this is 11, and this is 12. So we have 3 out of 36 possibilities of probability A. So this is how you're supposed to basically do this. And you can just simplify it as 1 by 12. Now, similarly, we can have the tossing of a coin. This is just rolling of die. You can have any kind of outcome that you desire. So this is basically the event, which is a subset of all the possible solutions of the sample space. Now this is favorable. Similarly, we have coin. We could have head or tail, but the number of times that we toss is more important. In the book, you have to 3 or 4 times. So you can always have some sort of like a branched out thing, where you could have head, tail, then head, and then it's the possibility of a tail, and then it's possibility of a head or a tail. Then again, this is basically based on the third toss. Now again, you can have head, tail, then you can have head and tail, head and tail. Now if I were to draw a sample space based on this, the third toss that we have, you can see this is head, head, head. Then we have head, head, tail. Then we have head, tail, head. Okay. Then we have head, tail, tail. Then we have tail, head, head. Then we have tail, head, tail. Then we have tail, tail, head, and tail, tail, and tail. So you can just count them: 1, 2, 3, 4, 5, 6, 7, 8. Let's just see that these are the number of possibilities that we have right now. Yes. So now if I want to find out the number of possibilities out of which we could have 2 heads or more, let's suppose. So this is probability of A, could be 3 heads, then head, head, 2 or more, so it's head, tail, head, again we have tail, head, 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 and then we don't have any more, so now these are 4. So I can say out of the possibilities of 8, we can have 4 out of 8, which is again, in this case, half. Simplifying. We can have further more outcome, which is the simplest diagram that I have drawn at the moment. So you can just, based on that, even if you don't draw this, you can just simply write head, head, head. Then you can just remove this with, or replace this with T, then center, then tail, head, head. Then you can have again tail, 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 head, tail, tail, and so on and so forth. Okay, now then there's another concept which is linked with intersection. So then there is a sign which is intersection, then we can have union as or and intersection as and. So if I say if it is hot and humid or hot, so there is and dry, right? So then in this case, as you can see, A is hot, B is humid, C is dry. Then hot and humid in this case would be A and intersection B, or hot and dry. So this is going to be this probability of hot and humid, union, probability of hot and dry, something like this. So this is intersection and union, interplay. Then there is another concept which is known as complement, which is something which is not existing in probability of A. So in this example we had A as where it could be 11 or more. Then A complement in this case, sorry, this was probability of A, or N into probability of A, whichever that you think. Yes. Probability of A. Now N into probability of A complement, what would that be? This would be 36 minus 3 would be 33 by 36, because all these combinations would not have 11 as their sum when you roll 2 separate die or 2 dice. This is a plural of die. Let's just begin with the book now. Let me just see what time is remaining. Alright, I think we do have time at this time. It's crucial to also inform you that since I'm recording in DSLR, I have to be pretty quick, because it gives us the time span of 30 minutes to record. Now let's just revert to the book. Okay. So I gave you an example where, okay, they also talk about another example why probability is important is because if you have like a show like this, let's make a deal, is where something like maybe some a lottery show or some kind of a game show that happens where they would call upon a contestant or a participant to choose between 3 options, 3 doors, 3 cars, 3 numbers, behind which there's going to be a prize. So maybe you choose this, okay, this one. And he would come and unlock this option and see that there's no prize behind this. So he would give you an option of whether you want to revert to some other choice or you want to, be consistent with your earlier choice. So now there's a probability that either could have is half. So what's the use of probability in the first place? This is about the possibilities that you could have, a number of possibilities that could result and give you various possible answers. So I have explained to you what is an experiment. You are supposed to know this: outcome, sample design, sample space, So this is, okay, another interesting example. They have indistinguishable dies, which would mean that these are perhaps not distinguishable, and they want to find out what, okay, so in this example, they want to perhaps know which is the number higher or equal to the number occurring on the left side. So you know this is the lowest one, all will be more than this or equal to this, but for this 2, 1 would not be included because this number is heavier than this side. So I'm going to be drawing it off. All the numbers on the right side should either be equal or more. So we would be having something like this, 21 outcomes, right? And this is the 21 outcomes we have. Then we have a number of other, selections. Okay, this is important because this talks about combination. Collection of 2 cards from chosen of 10. Now, as I said, this is without regard to order, because when order comes, then we talk about permutation. And in this, we are going to talk about randomly selecting from a fleet of 10. So how you're to do this is basically 10 combination of 2, which is 10 factorial 2, which is 10 into 9 by 2. So this would be actually again a 90 by 2, which would be 45. So in this case, this is C is the collection. Okay, it doesn't stand for combination, just mind you. And let's just move ahead with the question. If I want to just explain to you hurriedly about the question, this is a very simple section. This is section 7.1 of Finite Mathematics by Stefan, Waner, and Stephen Costinoble. Okay, this is the tree diagram I've already explained to you in the lecture. You can just look at this one. Then event is just subset. I've already explained that as well. Showing the same number. Okay, so this is very simple. And there's the concept of a null set where it cannot exist because there are no favorable outcomes. The sum of numbers should be 1 because we already know that 1 is the least unless the other die is crooked. We cannot have 1, right? So, and then another example is that maybe many questions are asked by students that what if the coin lands on the edge when you're tossing a coin? So we're assuming at this time that that possibility is remote, so we just keep it aside. Then experiment is when you take an action. Okay, I would want to explain to you, okay, these are all the possibilities out of whatever that they want you to come up with. Any kind of desirable answer or solution. Similarly, we have, you can just look at this T diagram. I think it's not difficult. Complement, union, intersection of events. So now we just see that 4 shots at the goal. This is set of outcomes. They describe the event that you score at least twice. At least twice would mean 2 and more. That would be E. But complement would be something which is not twice or more, so it would be 0, 1. Similarly, union is, as I said, an event when you roll a die is 5. Outcome is an even number. So for a union is an OR. So the outcome is in either a 5 or an even number, so you're going to just add them up as 2, 4, 5, 6. Okay? You're not going to be taking common. You're just going to be adding them up, this or this. So you're just going to be having this. Intersection would actually be this and this. So this is, the red die is 2, the green die is odd. So the intersection could be 2 and the green die is odd. So it could be the green die 125 is odd, and this could have all possible occurrences with 2. And the weather example, I've given you a similar example. Please look into this. It just shows to you, okay, then that it would rain, or it would be pleasant. And with pleasant it's P, rain is this. And then C with event will be cold, and H will be that it will be hot. So express in words, if I say that this is raining, and probably it's not going to be pleasant because it's P complement. And this is raining. Okay, now this is if it is raining, and this is intersection. Okay, so for this is raining and this is going to be for Unit is going to be raining or having pleasant and cold. Okay, so now let's just look at this. Rain will be pleasant and cold, and it will be raining and it will not be pleasant. So this is how you explain it, and then you can just also have it in symbols like I told you. We have many examples. Just look at this section. Okay, I've given you the answer for 3 probabilities, 3 possibilities out of when you roll a die for 3 times. Okay, so now 2 coins are tossed. The result is most 1 tail. This exercise, what it would mean is when you have the coins tossed, 2 coins, okay, it would be head, it could be head, tail, head, tail, at most 1 tail. So that would mean, could be this, at most 1 could mean that there is either 1 tail or no tail. So it could be this, oh sorry, this is tail, right? So we would be excluding this possibility, this we can have all 3. Similarly, you can just do the second one. Let me see the time. Okay. Now where we have 2 coins that was, the result is 1 or more heads. Again, 1 head, or we can have more heads. So again, the same answer, right? 3 or 4. Now third is 3 coins are tossed. The result is at most 1 head. So at most 1 head, I think I just gave you one of the examples in which I already did this. So there was at most, or I think I said 2 or more. So you can just have the same drawn as the number of heads with the 3. It's easier to draw, and then the result is 1 or more heads. So I can just simply tell you that it is head. Then this is at most 1 head. So we are not going to be having this. We are going to be having tail, head, tail. We could be having tail, head, or we could be having tail, and yeah, I think these 4 possible outcomes would be there, because we can't really have 2 heads, because they have asked us to have at most 1 head, so we can just have 4 outcomes in this case. So you can just draw the diagram to see actually if this is the case. Okay, now let's just look at some various questions. Okay, now see, this is a question where okay, so they have given you this letters chosen, Mozart, okay, the pianist, famous one, and from those the letter is a vowel. So now you know that from Mozart to O, and we have A. So out of this 3, 4, 5 and 6. So we have 2 out of 6. Is the possibility that a letter is chosen at random. So it just could be O or it could be A. The letter is a vowel, so it is therefore the probability would, in this case, the letter is chosen is 2 out of 6. Yes. Now similarly, we could have a set as you can just simply say that event. You can just simply say that event is a vowel, and the probability of A would be, having O-N, A. And then this could be for NA, could be having 2 by 6 or 1 by 3. Similarly, we have other sequences here, sequence on the similar pattern. Okay, now this is an interesting question 30. Either the numbers add to 4. Okay, what is this? Suppose 2 die, 1 red, 1 green are rolled. Consider the following events. The red die is shown, B adds, and C at least the number is 1. Okay, so the red die is, okay, they have already explained to us the events. Now either the number adds to 4. We can already have our own in this case, but what they're asking us to do is express the stated event in symbolic form and say how many elements it contains, right? So now either the number adds to 4 or, so I said it's a union is going to be probability of A is, so first of all I'm going to be defining A as adding to 4, B as add to 11, let's say. To 11 you can just have any kind of events, or you can just term it as the numbers do not add to 11. Okay, this is going to be D complement, sorry. Why? Because I already explained to us that D is the numbers that do not add to 11. So that means the number that do add to 11 is D complement. So it does not necessarily mean that it has to have a not inside for complement. It would be the other way around. Or at least one of them is C, is 1. At least one is 1. So now when we are going to be explaining in terms symbolically, like I said, intersection or complement, so now they add to 4. So this is A first of all, or this could be, if it's a probability, then you can have the numbers adding up to 4 for a die, right? So you can just simply add them and see what is the probability, but right now symbolic would be that it is asking us for a union of, again, add to D complement. Or this is at least one of them is 1. So it's going to be probability of C. That is only if in terms of number that you are doing. So now if I open this up, I'm going to be having as probability of A union, it could be D complement. Okay, A union C. Okay, but for just symbology, you can just simply say that A, it is union B, D complement, sorry, and union C. So this is OR is basically your union, and intersection would be AND. OR would be a union, and if I would change this to AND, then I would be replacing this with an intersection like I just did. These could be this. But then there could be another way around, that they could be saying this possibility and the possibility that they are occurring together. Then we would be having an intersection in this case. I hope that you can see that basically what is meant by frequency. So just supposed to read this stuff. Frequency would, basically frequency is the amount or the occurrence which is repeatedly done. So if an event has been isolated as the number of times head appears out of toss. So amount of times that head would appear is the number of times that that event was repeated. So as many times had come, so that means heads have repeatedly turned up in further tosses. So in this case, the relative frequency would be the iterations, which is actually the number of repetitions, and that would be as the denominator. So now the numerator would actually be the frequency as the number of times that the head actually or the tail came up. So that event is isolated, and then you can simply find out what is the total value in percentage. So you always represent this frequency or estimated probability in terms of decimals. Then you can just read upon, it's also known as the fraction. Similarly, we have this experiment is repeated 100 times, and 10 times the rolling frequency would be the event that it has been rolled 10 times, it's actually 10%, it's 0.1. I would like to give you another example of a hybrid vehicle. Now, in a survey of 250 hybrid vehicles sold in the United States, 125 were Toyota Pride, 30 were Honda Civics, 20 were Toyota Camrys. What they are going to be asking is where you isolate events where there is no Toyota Camry. So you need to find out how many vehicles were sold. So this is going to be your N in this case, 250. Now, what is the relative frequency that a hybrid vehicle sold is not a Toyota Camry, and how many were Toyota Camry in this case? 20. So you're going to be subtracting 20 from here, so you have 230. So then you're going to be dividing 230 by 250. This is going to be your relative frequency, as you can see. The N is 230 by 250, which is 92%. You can just simply find it out in the form of sample space, and then you compute the values. And then you can see there's another example, shows survey of the bid prices for 50 paintings on eBay with the highest number of bids. So now in this in this kind of an example where there's a class division, you can simply add these values up as 23 plus 15, and then this is going to be 15 and 25%. This is going to be 50. Okay, this total is 50, and out of this bid within 0 to 9.99 is 6 by 50. This is the relative frequency. The frequency is 6, but the relative frequency would be 6 by n, which is 6 by 50. And for 10 to 49.99 is going to be 23 by 50. And for 50 to 99 is going to be 15 by 50. And anything above $100 is 6 by 50. As the value keeps increasing, the the number of bids has reduced, which are going to be giving you perhaps more than $100 in this case. So now you can see this is 6 by 50, 23 by 50. So now if you want to find out that a painting had a bid price of less than 50, as you can see the less than 50 would be both these values. So you're just going to be adding both these values, 0.12 and plus 0.1 plus 0.46 is going to be 0.58. So then you can just simply look at these similar examples, similar questions. Okay, now if the number of iterations or the number of times an experiment is repeated, the values tend to focus on a central value, which is the main probability in this case. So the highest, as the highest value of n would actually yield the real probability value. So just read up on this as well. And then we have questions. I won't be asking you questions from the section, but I would be definitely asking you similar to the concept in the examples. So you have to look at this concept of relative frequency as well as section 1.